This is lesson 8-8, surface area, and it starts in your workbook on page 482. This is example 1 on page 482, and it says, a city planner wants all neighborhood parks to have more green space than non-green space. Does this park meet the requirements, and explain? So we're going to be dealing with area. And it looks like the green spaces are what we're going to call composite figures. And you're going to see that that definition is right here. A composite figure is simply the combination of two or more geometric shapes. And as I'm looking at that, this looks suspiciously like a rectangle. And this one I think we can divide into a rectangle and a triangle. So because we are talking area, let's do a really fast review. If we want to find the area of a rectangle, we're going to take length times width. And if we want to find the area of a triangle, we're going to take half of the base times the height. So remember, we're trying to find out whether or not the park meets the requirements. So over here, we actually have our shapes all nicely divided. So we're going to find the area of the green spaces first. So this green space right here is 12 by 14. So if you pick up a calculator and you take 12 times 14, you are going to get 168 square feet. Let's do this rectangle right here. This is 12 by 35. 12 by 35, if you pick up your calculator, is 420 square feet. I'm going to circle our answers here because we're going to have a lot of numbers in a minute. And then this triangle is half of the base, which is 24, times the height, which is also 24. So if you pick up a calculator and you take 24 times 24 and you divide it by 2, that rectangle is 288 square feet. So our green spaces make up 168 and 420 and 288 for a grand total of 876 feet squared. Now to find the area of the non-green space, we have a couple of options here. We can take the entire big rectangle, green and blue together, and take out the green space, or we could continue to practice our areas. Let's go ahead and think about this as one big rectangle. It is a 12 and 24 makes 36 by 35 and 14, which makes 49. So our big rectangle, the whole shebang, is a 36 by 49 rectangle. When I multiply those, I get 1764. So if you remember, we have this divided into two different things. We're going to take the entire, let me get rid of that number. We're going to take the entire 1764 rectangle. We're going to get rid of the green space. The green space is 876, which should just leave us with the blue spaces of 888. These are the blue spaces. So let me do some highlighting. We've got a lot of numbers on here. Our green spaces are this much, and our blue spaces are this much. And if you remember, we wanted to know, the city planner wants to know if we have more green space than non-green space. And the answer to that is we don't. The green space is only 876, and the non is 888. Now, if you look through the example in your book, you're going to notice they did it slightly differently. That's okay. That was done on purpose. I want you to remember that there's always more than one way of going about a problem. And just because your method, in this case my method, and the book's methods were different, doesn't mean one of us is wrong. It just means we did it in a different manner, and we ended up with the same conclusion. This is the try it at the bottom of page 482. And it says this diagram shows the area of a room to be carpeted. What will be the area of the new carpet? Okay, so we have a lot of boxes here. So let's go ahead and assign some of them. So this is the area. Let me change that to a pen and not a highlighter. This is the area of section A right here. That is a rectangle, so we're going to take length times width. It is a 5 by 6 rectangle. A 5 by 6 rectangle gives me 30 square feet. Then we're going to look at section B. It's a triangle. So I'm going to take half of the base. Ooh, wait a minute. I don't know the base. I know all the way across is 9. And from the top of the rectangle, I know the bottom of the rectangle is 5 plus something makes the entire 9. I feel like the base of that triangle is 4. One more time, the entire distance was 9. The rectangle took up 5 of that, so it left the triangle with 4. So that is half of 4 base times height of 6. 4 times 6 is 24. 24 divided by 2 is 12. Half of the base times the height. So we're going to take the rectangle. We're going to add the area of the triangle, and we are going to get the grand total of 42 square feet. This is example 2 at the top of page 483. It says Gavin constructed a model building and wants to cover the outside with paper. How much paper will he need to cover the entire model? All right, so what your book did is they took this three-dimensional shape and they laid it out flat, and that is called a net. So that is what you are looking at there. And they're going to find the area of each of those shapes and then add them together. Let me show you an alternative. So I'm going to look at Gavin's model, and I notice that there are 4 brick walls. So I'm going to start with the area of the front brick wall and the back brick wall. And that is 24 by 12. 24 by 12. Or if I went ahead and multiplied 24 by 12, 288. Now I've got a front and I have a back, so I'm going to need 2 of those 288s. All right, now I'm going to find the area of the left and the right. So the left is 12 by 12, or the right, however you're seeing that. 12 by 12 is 144, and I have both a left and a right. And then I have a bottom, but I'm not going to have a top, because if you notice, the top is not on the outside of this shape. And so the bottom is going to be 24 wide by 12 long, that is another 288. So I've taken the brick building and I found 5 of the sides because the 6th one, the top, isn't included in the outside of the shape. And now I need to do the roof. So the area of the roof, so this is 24 by 10, or 240, and I have a front panel and I have a back panel. And then I have 2 triangles on either side. And the area of a triangle is half the base, which is 12, and the height. Now this one I have to think about a little bit. It's 12 from here to here, but it's 20 all the way. So if this part is 12, the rest of it has to be 8. So if I take half of 12 times 8, I'm going to get, let me do that real quick. 12 times 8 divided by 2 is 48. And I have a left side and I have a right side. All right, it's time to add all of these areas together. So we're going to have 288 and another 288. That's for the front and the back. 144 for the left, 144 for the right. I've got 288 for the bottom. I have 240 for the front of the roof, 240 for the back of the roof, 48 for the left triangle, and 48 for the right triangle, for a grand total of 1,728 square centimeters. Oop, I covered up my 1. 1,728 square centimeters. This is example number 3 on the bottom of page 483. And again, we are trying to find the surface area of a composite figure. And one more time, when your book takes a composite figure, a 3-dimensional figure, and lays it out flat, this is called a net. So that's the cube on the bottom, and this is the net for that pyramid on top. All right, now I'm going to do it just a little bit differently. They're going to find the surface area from the net. I'm going to find the surface area from the shape. So let's look at the cube on the bottom, and I know it's a cube because all the sides are the same. It's a 6 by 6 by 6 cube. And so I'm going to find the area of just one of those faces. Let's do the front because they're all going to be the same. It is a 6 by 6, which is 36. But let's think about how many sides there are. There's a front and a back, a left and a right, a bottom, but no top on the outside of the figure. So I have 5 of these faces, which are 36 square inches. So if I take 36 times 5, I'm going to get 180 just for the cube. All right, now it's time for me to take care of the pyramid on top. Let me do a triangle. All right. So a triangle is half of the base, 6, times the height, 4, and that's going to give me 12. Now let's think about how many of those we have. So we have a front and a back, a left and a right. So I'm going to have 4 of those. Surface area means I'm going to add them all together. So I'm going to take 180 and I'm going to add the 48 to get a grand total of 228 inches squared. This is the try it on the bottom of page 483. Hiromi is painting the front and back of a barn. Each can of paint covers 32 square feet. How many cans of paint does Hiromi need to cover the entire front and back of the barn? Okay, so if I'm looking at this barn, the first thing I'm going to notice is that I think that this front side might be a composite. I might have a rectangle and a triangle. So let me find the area of the rectangle. And it is a 12 by 11. You're going to pick up your calculator and you're going to multiply those. Let's talk about the area of the triangle on top. It is half of the base. The base is 12. And the height, now, wait a minute. I know that this amount is 11 and the total is 15. So I feel like that might be 4. All right, now I've given you some help to get you started. You're going to find the area of your rectangle and you're going to add the area of your triangle. Remember, he has to do the front and the back. And then finally, once you have your surface area, each can of paint covers 32 square feet. So how many cans of paint are needed? All right, at this point, I want you to pause me and work out the rest of that problem and then come back for checking. All right, when I took 12 times 11, I ended up with 130, oops, let me undo that, 132. That was for the rectangle. When I did my triangle, half of 12 times 4 is 24. I'm going to add those two things together, and I'm going to get 156, which is awesome, but that's only the front and the back. So I need 312 square feet, of paint. Well, I can cover 32 with one can. So let's take our total divided by one can. I'm going to pause you here, finish the problem, and come back for checking. This comes out to be 9.75 gallons, but they don't sell partial gallons, and 9 wouldn't be enough. So we need about 10 cans of paint. This is your key concept on the top of page 484. It says the area of a two-dimensional composite figure is the sum. That means you're adding of the areas of all the shapes that compose it. The surface area of a three-dimensional composite figure is the sum of all the areas of its faces. So you're just going to take and you're going to add the areas of everything together to get a grand total called a surface area.